Welcome back to our course in college algebra. In this video, we are going to talk about where functions are increasing, decreasing, and constant. In the past couple of videos, we have discussed slope, rate of change, and difference quotients. Okay, now those are all related ideas, and they are all about telling us how the outputs of a function are changing with respect to a 1 unit increase in the input. In other words, what is happening to y every time you increase x? So, if an increase in the input leads to an increase in the output, we call that an increasing function. If an increase in the input leads to a decrease in the output, we call that a decreasing function. And if an increase in the input leads to no change at all in the output, we call that a constant function. Okay, now all of these have graphical manifestations. You can see it in the picture. If a function is increasing, its graph will rise as we go from left to right. If a function is decreasing, its graph will drop as we go from left to right. And if a function is constant, its graph will be horizontal, going from left to right. Now, with linear functions, if they're increasing, they're always increasing. And they're always increasing at the exact same rate, determined by the slope. But not every function is linear. This function right here, for example, increases and then decreases. Okay? Now, this function is increasing on this interval, okay? Negative infinity to 1. When we talk about where a function is increasing and where a function is decreasing, we're talking about the portion of the x-axis where this is happening. Okay, so this function is increasing up until you get to this point. How do we determine where this is? Well, that's where x equals 1. And this is decreasing on 1 to infinity. You might want to go back and look at the video that we did on interval notation if you need a refresher on what this is talking about. Okay, but the thing I want to emphasize is we are talking about the x-axis where this is happening. Okay, so here the graph is sloping up, and that happens until you reach x equals 1. And then after x equals 1, the graph is dropping. So the function is decreasing. Let's look at another example. So, different graph. Once again, y equals f of x. I'm not even telling you the formula for this function, I'm just giving you the picture. If you go back and look at our video on how to read graphs, you'll see why that's enough. All we need is the graph. We've got everything we need to know about the function from the graph. Okay, here, f of x is increasing on the interval 2 to infinity. Right? We can see in this portion the graph is dropping. In this portion the graph is rising as we go left to right. Okay, so imagine we take a pair of scissors and we cut this into two pieces. Here's the decreasing section, here's the increasing section. Where is this happening? Well, this is all happening. The decreasing part is happening until x equals 2. And then, after x equals 2, it starts to increase. Remember, positive infinity lives way over here, negative infinity lives way over here. And when we're talking about where a function is increasing, decreasing, and constant, we are talking about the portion of the x-axis where this stuff is happening. So this function is increasing on 2 to infinity and decreasing on negative infinity to 2. Okay. One more. Okay, this is my function. Not going to give you the formula, just going to give you the graph. Okay, a couple things to pay attention to. Notice over here, I have a filled in dot. The graph just stops there. There's nothing to the left of that. Over here, I've got a little arrow that indicates this continues forever. Okay. This function is increasing on just a little tiny portion of the graph. I would recommend you kind of draw these lines, kind of cut the graph up. Okay, well, where's this happening? This is this vertical line, that's x equals 3. This vertical line is x equals 4. The function is increasing on that interval, sloping up. So the function is increasing on that interval. Okay, decreasing. Let's look at where it's decreasing. Okay, well, looks like the decreasing thing starts here at x equals negative 3 and then continues till x equals 0. Okay, so negative 3 comma 0, that is one interval where the function is increasing. Now here it's flat. Remember, sorry, that's an interval where the function is decreasing. So decreasing here. Here it's flat. That's constant, remember. So increasing, graph sloping up. Decreasing, graph sloping down. Constant, graph is horizontal. But then the graph decreases again over here from 4 on out. Remember, since we want to consider both of these together, we are going to union the two intervals. Okay, the union symbol looks like a U. So the function is increasing on this interval, decreasing on the union of these two intervals, and constant on this interval. Okay, and with all these things together, we've tackled the entire domain of the function. The domain of this function is negative 3 to infinity. Look back at our video on finding the domain and the range from a graph, and you'll see that. Okay, so remember, big idea when we're talking about where is a function increasing, where is a function decreasing, where is a function constant. We are talking about the intervals of the x-axis where that is happening. I would recommend, if you've got the graph, just draw these vertical lines here and indicate the equations of those vertical lines. And that'll tell you what to do for the bounds on your interval notation. Okay, so increasing, decreasing, and constant functions.